Okay, so today we are going to start statistics for data science and machine learning. Okay, as like linear algebra, statistics is also a very important topic in DS and ML because here we have to show the statistical representation of the data. That means how data is statistically distributed. That's what we are going to show in this particular topic. And it has always been a hot topic. Fine. And if you are working with the data, obviously statistical analysis is very much important. Fine. So what is said here? A powerful mathematical field, stats. We are having separate courses for statistics. Okay, people do perform the graduation and post graduation on statistics. Okay, so they totally work upon data and do the analysis. Okay, powerful because it helps us to infer a population outcome over sample data. That means statistics helps in telling telling an outcome from sample to population. This is how statistics help. So with sample only, I can tell something about population. Population is a big amount of data, huge amount of data. That is population. Sample is a small amount of data. So by analyzing the sample, if you can do something, if you can tell something over population, that comes under statistics. So with linear algebra, you are performing vector and matrix operations. But here things are a bit change, and in statistics, I will be talking about inference. Okay, so statistics is not only a combination of isolated topics, it is helping in discovering new semantics within these topics. And we do use statistics in our day to day life. That's what important this statistics is. Okay, so it combines techniques for drawing reliable conclusion over a data. Very much important to derive a conclusion over a large data by experimenting on small data. Okay, very important line. This is what statistics means. And you are summarizing your data set. Okay, you want to locate a point over a 2D, you did by coordinate system. You draw vector to them, you represented them in 1D format, 2D format, matrix format, and you applied matrix transformations to solve the equations. But in case of statistics, the data is given, huge data is given, we are drawing sample from it, and we are giving some conclusions about a large data about population by experimenting over sample only. Okay, so what's the example? We have elections. Okay, and let us suppose in your city the news group, they are doing survey that who is going to win. the election. So if in your city you are having 1 million people, it doesn't mean that they are going to survey all, they are going to ask the questions to all. No, they don't do this thing. They will pick up 1,000 people only. This is sample. And whatever these 1,000 people are giving the opinion, they will draw the conclusion over this opinion for 1 million people. That's what they will do. Okay. Statistics perform this thing. Okay. So statistics is the discipline that concerns the collection, organization, analysis, interpretation, and presentation of data. Many things. Collection of the data is also under statistics. Organizing data is also under statistics. Analyzing data is also under statistics. Interpretation of the data, this is very much important. It is under statistics. Analyzing is also very much important under statistics. And presenting data. Okay, all things come under statistics. If someone asks you, what do you mean by statistics? You have to say all these things. Okay, fine. Any of. Okay, fine. All right. Fine. So, this is the definition of statistics. All right. In general, statistics is divided into two categories: descriptive and inferential. Descriptive statistics and inferential statistics. Descriptive statistics is a statistic that summarizes descriptions, whatever you want to say, you can. The population or sample data. Descriptive. I'm going to write summary of data. This is descriptive statistics. For example, you can tell mean, median, mode, maximum value, minimum value, count. All these things you can tell about the data. It comes under descriptive statistics. Okay, type of the data, variable, data representation, frequency, distribution, central tendency. This is all central tendency, mean, median, mode. Percentile, quartile, covariance, correlation, all these things comes under descriptive stat. That means I'm describing data. I am writing summary of it. Okay. So this comes under descriptive statistics. And when I was also learning this statistics, na, I was like, statistics only means mean, median, and mode. At that particular time when I was also kid, I was learning statistics. I think that okay, statistics means mean, median, mode. That's it. But statistics is having many things. Okay, as I explained here in the definition: collection, organization, analysis, interpretation, presentation of the data. And two forms: descriptive and inferential. In descriptive, you are having measures of central tendency, which is mean, median, mode, and there are other things also: frequency calculation, data representation, percentile, quartile. That I will let you know what this percentile and quartile means. Okay, that I will teach. Fine. Covariance, correlation. This all comes under statistics. Descriptive. Inferential is drawing hypothesis. Okay. Inferential means drawing hypothesis. Okay. I need to find reliable inferences of population data from sample data. Okay. That means hypothesis testing. Okay. That means that's what I explained just recently. Like you are doing survey in elections that who is going to win. So you collected sample, and This is the population. Okay. And you are drawing inferences from sample over population, that this is the public opinion and that party is going to win the election. And that's the same ideology of 1 million people also. So drawing inferences. Okay, so there will be a statement. That statement is called as hypothesis. Okay, and hypothesis will be given, a statement will be given. In inferential statistics, you have to prove the hypothesis, whether it is correct or wrong, whether it is correct or incorrect. That we will see in inferential statistics. That we will see here. So, inferential is a part of statistics that find reliable inferences of population data from sample data. How population and sample are connected. Okay, if I am saying something over sample, whether it is related to population or not, whether that statement, whether that hypothesis is going to be true or not, that's what we do in inferential statistics. So it tells you about probability distribution, central limit theorem, point estimator and estimate, standard error, confidence interval, okay, significance level, this is very much important. Significance level, hypothesis testing, analysis of variance, chi-square test, ये सब these all na are hypothesis testing only. All are hypothesis testing. Okay, so we do perform this testing in our data science, hypothesis testing. Fine. So it is also one of the part of statistics. Fine. Now let's understand some terms. Population and sample. See, name itself suggests it's a very simple thing. Population means all the data points. Sample means it's a subset of a population. Point is clear. So population consists of all the members. Sample consists of some selected members. That's it. It's a subset. Okay. Now you can take any example. We want to know university students' CGPA. For experimental purposes, we cover all the students, so that will be population. And if we pick up some students, then it will be a sample. That's it. It's just like a common thing. Variable and level of measurement. Variable is something which can vary or hold multiple values. Okay, we do define variables in our programming languages. Okay, just like now, x equal to 5, x equal to 10. So here x is a variable, okay, which can hold multiple values. All right, and we have seen a variable in our data set. It's not new to us. Our data is having variables, no, features, no. Fine. So there are different types of variables, and I already explained you about data, classification of data. Okay, and we should know the measurement level to understand how we can deal with the data, how we can measure these variables. Okay, so variable, feature, and there are different types of features. Okay, we can have numerical feature, we can have a non-numerical feature. So how to represent them, that is very much important. It comes under statistics. Okay, central tendency, measures of central tendency. This is what the topic I like very much when I was also studying in school. Measure of central tendency. So central tendency is a way to find the tendency of majority values. Okay, where they are tending, where is the alignment. Okay, so we are having mean, median, and mode, and you very well know about these things. Mean, it is straightforward. That means mean is the average. Just calculating average of values means it's mean. Okay, this is how you can write summation of x divided by n. That means calculate the sum of all the values divided by total number of values. This is mean. It is given by bar x bar. This is mean. Okay, what is median? Median median is another way of central tendency, and median is the middle value actually. Okay, median is middle value, and to find the median, we have to first arrange the data in ascending order. We have to arrange the data in ascending order. That's what we have to do. Okay, arranging data in ascending order and then find the middle value. Okay, fine. Now, data can have even number of values also. Data can have odd number of values also. Okay, for example, here 12, 13, 10, 15, 7. I need to find the median of it. So first you have to arrange them in ascending order. So 7, 10, 12, 13, 15. This is the arrangement in ascending order. How many terms are there? 1, 2, 3, 4, 5. 5 terms are there. So if there are odd number of terms, so the median value is the center value. That means the formula is n plus 1 by 2th term. That means that means 5 plus 1 by 2, 2th term. That means 6 by 2th term. That is third term. So third term is the median. So what is the third term? 7, 10, 12. 12 is the third term. Okay, so the median is 12. Okay, median is 12. Just remember. All right. Now, what will happen if you are having even number of values? What you are going to do to find the median? Again, arrange it in ascending order. ये तो rule है. Arrange in ascending order. So these are the values, and I'm ascending in. I'm arranging in ascending order. So 7, 9, 10, 12, 13, 15. And according to the formula, for if the number of terms are even, it is written as like this: n by 2th term and n by 2 plus 1th term. Okay, so how many terms are there? 1, 2, 3, 4, 5, 6. So 6 by 2th term and 6 by 2 plus 1th term. That means third term and fourth term. Third and fourth. Okay, third and fourth term. See. So third and fourth term. Okay. So calculate the mean of third and the fourth term. What is the third term is 10, fourth term is 12. So 10 plus 12 divided by 2, 22 by 2, 11. So median is 11. See, very much important these are, because these measures of central tendency are used in imputation. Okay, in imputation, to fill null values, to fill null values in data. Okay, so that's why they are very much important. Okay, you have to understand the distribution of data, and then you have to, according to the distribution, you have to calculate the mean or median or mode, and then you have to fill the null values, because data is not like na, every time complete. Data is a raw data na? And you may have empty values in the data. So how to fill the empty values in the data? By calculating these mean, median, and mode. I will let you know by which value you are going to impute, that you will understand. The third is mode. Okay, so mode means number of times, highest number of times a particular value appeared in a data. That is the frequency, highest frequency. For example, good, bad, normal, good, good. So good, good, good. Three times it appears. So highest frequency is 3. That is good. So the mode of the data is good. Okay, fine. All right. So these are measures of central tendency. Okay. And as I already told that when to use which measure of central tendency. Okay, let me share my entire screen now and help you understanding. Very important concept. Now I'm sharing the entire screen and we will understand that how we are going to use them in imputation. Okay. Now this is your data set. You are available with the data like Excel sheet or whatever. Okay, this is your data set. X1, X2, X3, X4, X5. These are the features which are present in the data. Let us suppose these are the entries 1, 2. This is empty. 3, 4.5. Okay, this is A, B, A, A, and this is empty. Okay, this is empty. This is empty. This is 0, 1, 0, empty, 0. This is 1.1, 2.1, 3.2, 4.5, empty, and this is all filled. For example, this is filled like 1, 2, 3, 4, 5. Now I am having x1 with empty value, null values. Okay, x2 is also null, x3 is also having a null value, x4 is also having a null value. They are having null values. First you have to understand what kind of data x1 possess. 1, 2 dash 3, 4.5. Okay, it's looking like continuous data. Okay, you have to first check out what kind of data it holds. Continuous. X2 A B A A. Okay, categorical data. Categorical data. Okay, X3 0, 1, 0 dash 0. Okay, discrete data. X4. Okay, 1.1, 2.1, 3.2. Okay, continuous data. So you have to first check what kind of data it possesses. Now, let me talk about the imputation. In general, in general, for continuous, you can impute by mean and median. So you can fill the empty value which is present here by calculating the mean or by finding the median. In categorical or discrete, you have to impute with mode. Okay, you have to impute with mode. Here we don't have like mean or the median. Okay, for categorical data or discrete data, you have to impute with mode. Okay, now in continuous, you told that, sir, you can impute with mean or median. Okay, but when to impute with mean and when to impute with median? That is the question. Here again, the important thing is I need to check the distribution of data. Then only I will decide whether I should impute with mean or the median. अब उसमें भी mean is always preferred. Mean is always preferred, that if in a continuous data distribution you are having empty values, so you fill with the mean. That is the preference. But still, being technical, being sound in the concept, you need to check the distribution first. If a mean is greater than median, then impute with mean. And if median is greater than mean, then impute with median. And how? I will just let you know more about this thing when I will be talking about this distribution of the data. Okay, so I will be talking about the skewness in the data. Okay, skewness in the data. There I will explain again. So few things you have to remember. All right, fine. So this is how you can do the imputation. Mean is preferred, but there is issue with the mean. Okay, issue. What is the issue with the mean? See, mean is impacted by outliers. So we have to be cautious before imputing null values with the mean, because mean is impacted by outliers. Outliers are wrong or faulty entries present in data. Okay, present in data according to statistical analysis. According to stats, these are wrong or faulty entries present in data. Okay, so I have to clearly mention according to stats. So if I do calculate the mean will incorporate outliers, and you may have wrong imputation, wrong substitution in null value. So mean is affected by outliers. That's why I told you that if you don't have any outliers present in the data, and if mean is greater than the median, then impute with the mean. And if you have outliers present in the data, so be cautious. In that case, you have a chance to impute with median, because median is less impacted by the outlier. Okay, fine. So median is less impacted. In that case, median is preferred rather than mean. So you have to check the distribution, you have to check out the outlier, then take the final decision. Okay, that's what the data science and specialist says. Okay, we'll talk more about this thing ahead. Okay, now percentile, quartile, interquartile range. Very important concepts again. Very important concepts. Percentile, I guess you have heard a lot of times. In exams, in Indian, if I talk about in Indian exams, competitive exams, we do have percentile. Okay, for example, CAT exam, 100 percentile. The student scored 100 percentile. Gate exam or JE exams. Okay, percentile. So what is this percentile? Percentile is a measure used in statistics indicating the value below which is a given percentage of observations in the group of observations it falls. For example, 20th percentile is the value or the score below which 20% of the observations are found. See, it's very simple. Now, let me explain in my words. What does percentile mean? Percentile. Okay. You do divide data in 100 parts. Okay. Divide data into 100 parts. All right. In, for example, in exam, the paper is of 100 marks. A student, a student who scored 99 is topper of the exam. That means none of the student is having more than 99. The highest number is 99. He is the topper. This student. So we will say that 99 means 100 percentile. The highest marks is 100 percentile. It doesn't matter whether it is 99, 98, 97, 96, 94, 90. Doesn't matter. Highest marks is 100 percentile. Now, any student who score 98, I will be calculating its percentile with respect to 99 only. Okay, with respect to 99. Okay, so if 99 means 100 percentile, what does 98 means? You can find what does 98 means. All the scores will be calculated according to this only, 99. Okay, now what they told in the definition? They told 20 20th percentile. The definition says 20th percentile. It means that this is a value below which below which 20% of the data is present. Okay, recheck the definition. Percentile. 20th percentile is a value or a score below which 20% of the data is present. Now, if someone asks you, what is 50th percentile? You will say 50th percentile is a value below which 50% of the data is present. 50% of the distribution of the data. Let me clear it. 50% of the distribution of the data is present. This is 50th percentile. So again, come back to my example. I told the topper scored 99. That means, and I told that this is 100 percentile. That means all of the students are present below. All of the students are present below this number 99. क्योंकि भाई ये टॉपर है ना, तो सब इससे नीचे है ना. This person is a topper person. Okay, this is topper. So obviously, all the students are below this person. So if so that's why I told you 99 is 100%. That means 100%. 100. All the students are below this. The same thing, it's mentioned in the your definition, 20th percentile. That means 20% of the values are present below. So if I say 100 percentile, that means 100% values are present below. So 99 is the topper value. Rest all the values are below this 99. Point is clear. Now, any doubt, please let me know. If you have any doubt, please let me know. So if you say 75 percentile, that means whatever be the value 75 percentile has, below this value, below this value, 75% of the data is present. Okay. So right now, in the competitive exams, we do use, like, what? What we use? Percentile only. Okay. We do use percentile, not the percentage. Okay. Fine. So I hope you understood this percentile concept. Huh. So only the thing in percentile is we can have like till 99 or 100 percentile also, like, 99 marks, 100 percentile. So that means we are dividing data into 100 parts. Dividing data into 100 parts. Okay. That's what we can have in percentile. But okay, we have a huge data for analysis, huge data for analysis. So dividing data into 100 parts is not feasible, sir, every time. It is not feasible, sir. Can we have an alternative approach? Can we have alternative approach? That because now representing data in 100 parts is not like good always. Can we have an alternative approach? Yes, quartile. That means divide data into four parts only. Divide data into four parts rather than 100 parts. Okay, so if you are talking about percentile, so this is your data distribution and you are dividing data into 100 parts. This is percentile. But quartile, dividing data into four parts. Name itself suggests na core. Core means four only na. Okay, so dividing data into four parts. For that, I require 3 points: Q1, Q2, Q3. So three points can divide data into four parts, and I'm naming them as Q1, Q2, Q3. So Q1 is first quartile. Q2 is second quartile. Q3 is third quartile. Okay. Q2, which is second quartile, is also median value. This is median. Q2 is median. Don't think that, sir, it is a center value. यहाँ ये concept नहीं होता center फेंटर वाला. Q2 is median. Okay. And also Q1 means 25%, Q2 means 50%, Q3 means 75%. अच्छा, और ये लॉजिक सेम है परसेंटाइल वाला जैसा. 25% means this is that value below which 25% of the data is present. Q1 is that value below which 25% of the data is present. Q2 is that value below which 50% of the data is present. And Q3 is that value below which 75% of the data is present. Okay. This is how you have to understand. Okay, now let me show you the definition. Quartile. In the percentile, the entire value is divided into 100 parts, but we want to simplify our task. Okay, not 100. In quartile, we divide the data into four equal parts. Okay, each holds 25%. First quartile, second quartile, third quartile, and the fourth quartile. Main, we are having Q1, Q2, Q3 only. Okay, so here it is saying 25%, 25%, 25%, 25% distribution of the data. That's what it is saying. Okay, I also made the same thing. Okay, here it is. Okay, so 25, 25, 25, 25. Four parts I divided the data, 25, 25 each. Okay. However, our concerning these 3 points, our concerning points are these 3 points: Q1, Q2, and Q3. Okay. So Q1 first quartile 25%, Q2 second quartile 50%, Q3 third quartile 75%. Okay. So we have to put our data in quartile, and we have to identify the values of Q1, Q2, and Q3. Okay. Now here again, IQR, interquartile range, yeah, interquartile ratio. Q1 minus Q3 is IQR, interquartile range. Okay, so from here to here, okay, from here to here, this is IQR, interquartile range. Okay, Q1 minus Q3 is IQR. All right, and then what's next? Here it is. So Q1, Q3, this is IQR. Okay, this point is the minimum point. This point is the maximum point. Okay, this is minimum, this is maximum. Minimum is calculated by this formula, Q1 minus 1.5 into IQR. बहुत इंपॉर्टेंट है, IMP. So the minimum value in the distribution is calculated by this formula, Q1 minus 1.5 into IQR. And the maximum value of the distribution is found by this formula, Q3 plus 1.5 into IQR. This is called as 1.5 rule or Turkish rule. Okay, this is 1.5 rule or Turkish rule. So minimum value is calculated by this, maximum value is calculated by this. And this is IQR, interquartile range. Q1 minus Q3. Now, any value which is less than 1.5 minus Q1 minus 1.5 IQR, that is considered as an outlier. यानी कि ये गलत, these are wrong values, these are faulty values. And any value which is more than Q3 plus 1.5 into IQR, they are also considered as an outlier. ये भी wrong values है, faulty values है. Okay, so let me show this thing again here. You know Q1, you know Q2, you know Q3. This is 25%, this is 50%, this is 75%. Calculate IQR, that is Q1 minus Q3. Okay, calculate IQR, interquartile range. And if you find what is the minimum value of my distribution, that is written as Q1 minus 1.5 into IQR. This is the minimum value of your distribution according to a rule, that is 1.5 rule. And max is Q3 plus 1.5 into IQR. This is the maximum value of your distribution. Now, any value coming less than this value in your distribution, that is considered as an outlier. Any value which is less than this. Okay, so I can limit this thing. Min, max, we are having IQR here. Okay, and any value coming here, outlier. Any value more than this, outlier. And what are outliers? Those data points who are considered to be wrong or faulty entries according to statistical analysis. तो भाई मेरे ये statistical analysis ही तो है, ये क्या है ये? What is this? This is statistical analysis only. According to statistical analysis, I have identified that these points are outliers. Now, again, let me give you an example. Let us suppose you go to office every day. Not suppose, obviously you go. Okay, every day. Daily, you drive vehicle at a speed of like 30, 40 or 50 kilometers per hour or miles per whatever, 30, 40, 50. One day one day the road was clear, there was no traffic, less traffic, and on that particular day you drove vehicle with a speed of 80 kilometer per hour. Now if I make the distribution of the data of your speed, okay, speed, so mostly will come under 30, 40, 50, mostly will come under this thing. But 80, your max speed is 50, most of the times your max speed is 50. One day you drive 80. According to statistical analysis, it will be identified as an outlier. Okay, it will be considered as an outlier. However, one day you did this thing, but according to statistical analysis, outlier, wrong. क्यों? Because it doesn't matches the distribution which you are following on a daily routine. So this entry is like okay, a separate entry. It's not looking like should be present in a distribution. So it's marked as an outlier according to statistical analysis, but in reality you did this thing one day. But what I can do? I need to follow the statistical interpretation. Okay, fine. So this is what it means, like outlier detection. So why this quartile is important? Why? What's the reason quartile is important? Because we use this technique to identify outliers, to find outliers in data. Okay, and obviously it has been told to you that you have to remove outliers from the data. Okay, because outlier do impact your distribution of data, and obviously they will impact model ahead, okay, which you are going to train over the data. So we always expect a proper distribution of data. Proper distribution, that means we do have reference distributions, like for example in case of continuous, we do have normal distribution. This is our reference plot. Normal distribution. Okay, and normal looks like this. Symmetry. I hope you have seen many times such kind of. This is normal. This is a reference plot for us. Okay, and why reference? Because we do have the formula for this, na? 1 upon square root of 2 pi sigma e की power minus x minus nu का square upon 2 sigma square. This is the formula for Gaussian or normal distribution. If it is not, if the distribution is not normal, it will be considered as a skewed. ये left skewed है या right skewed? Skewness. That also we'll study. This is a skewed data. And the machine learning models. Okay, and skewness, why there is a skewness? Because of presence of outliers in the data. The skewness came into the data because of presence of outliers. Because these values are different from the regular values, so they are present far away. So I need to extend the tail, extend the tail to cover those points also. ये लफड़ा हुआ. Okay, I need to capture these points, so I need to extend the tail. Okay, if there is 80, you do drive between 30 to 50, but there is 80, so extension. So presence of outlier is responsible for skewness in the data. And also, if there is like and this the distribution is not normal, you may have some frequency values more in certain interval. So then also, like, okay, certain cases like this is also, there are many things. Okay, and the models, the machine learning models do require, for example, linear regression. If I do talk about linear regression, it says that I want normal distribution, then only feed the data into me, else don't feed. मेरे को normal मांगता है. I want a normal distribution. If you are having features, if you are having features which are numerical, which are continuous, and check how they are distributed. If they are not normally distributed, kindly transform them into normal. ट्रांसफॉर्म करो उसे नॉर्मल में, तब मेरे को देना, ऐसे मत दे देना, नहीं तो सब गलत हो जाएगा. ट्रांसफॉर्म them and then give it to me, else don't give it to me. Okay, so data distribution is very much important. Model only works good when you are feeding them the correct data. That is why we do have a steps in data science and machine learning. Data pre-processing. Data pre-processing. Okay, we do clean the data. We do pre-process the data and convert them into a proper format according to the expectation of a model. Expectation of a model. Else the model will give wrong result. Okay, so right now here I was concentrating about your quartiles. That means divide data into 4 parts. It is easier rather than working on 100 parts. Okay, so this technique of quartile, it is used for outlier detection. Remember always outlier detection. And in visualization, again remember, in visualization we do make box plot. ये जो दिख रहा है ना, ये भाई बॉक्स प्लॉट है. ये बॉक्स प्लॉट है. बॉक्स प्लॉट. बॉक्स प्लॉट. In visualization we draw box plot that will help me and help us to represent outliers. Outliers will be visible in box plot. So very important plot this is, box, to identify outliers, to see in the visualization. Why box plot? Because here you can see na, box is made. Box. This is box, IQR. interquartile range. Okay, got it. So this is min, this is max. Box plots show all the quartiles and upper and the lower fences. Okay, that means upper limit and the lower limit is shown by the box plot. So quartiles are statistical measure that divide data into four parts, each representing 25% of the data. They help us in identifying outliers or extreme values present in the data. We are having three quartiles, Q1, Q2, Q3. Q1 is 25 percentile, lowest 25% of the data. Okay, Q2 is second quartile, that is the median value, 50% of the data, and Q3 is the third quartile, 75% of the data. Okay, fine, 75% of the data. Okay, and this is the interquartile range, Q3 minus Q1 or Q1 minus Q3. Okay, you can write like this, Q3 minus Q1 also. It will work. Okay, Q3 minus Q1. So quartiles are valuable tools for descriptive statistics and data analysis, providing insights into central tendency. Okay, and we can draw quantile plot. Especially, see, I don't prefer this QQ, not that much. I go with box plot only. Okay, I go with box plot only. And in order to create the plots, okay, you have to first arrange the data into ascending order. Then only you can find quartile quantile. See, one more thing, quartile quantile means same. Okay, don't get confused. Quartile quantile both are same, no confusion. And if you need to find the quartile or the quantile, step number 1, arrange the data in ascending order. That means sorting. Sort the data. Okay, and then you have to divide the data into equal sized intervals. Divide data into equal parts. For percentile, 100 parts. For quartile, 4 parts. For decile, 10 parts. It depends what kind of parameter you are taking. Okay, so if I talk about the quartile, 4 parts, 3 parts. Okay, 4 parts, 3 values. Okay, Q1, Q2, Q3. For decile, 10 parts, 10 values. For percentile, 100 parts, 100 values. Okay, 100 values. Are you sure 100 values or 99 values you are going to take? To divide in 100 parts, obviously I require 99 values. Okay, so determining the corresponding quantiles from the chosen theoretical distribution. Okay, so that's called as cumulative distribution function. That is something okay, different concept that we can follow up ahead. Okay, so we do include box plots for outlier detection, and this quartile quantile concept is very much important there. Okay, so on the basis of the formula which I shown you here, minimum and the maximum, we can remove the outliers from the data. Okay, fine. So anything below 1 Q1 minus 1.5 IQR, this is outlier, and anything more than Q3 plus 1.5 into IQR, this is also outlier. So we can remove outliers from data using this formula. Okay, fine. So I hope you understood stats basics, measures of central tendency, when to use when. That I'm going to again catch up that concept, because I'm going to teach you skewness and the kurtosis. Okay, on the basis of skewness only we'll decide that which measure of central tendency we have to use for the imputation. Though I already clear you that point now, when mean, when median. Okay, but still I need to clear the points. Okay, so positive skewness means your, here you can see left skewed. This is right skewed. So positive skewness where mean is greater than the median. So here we have to impute with the mean. So for positive skewness, impute with mean. For negative skewness, median is greater than the mean. Okay, so impute with median. So you have to check the distribution of the data. Then you have to take a decision with whom I should be imputing. Very important. Okay, I hope this makes a sense. And yeah, yes, Ram sir.
Sir, I didn't get what is the meaning of meaning of impute. Mean
Imputation
is
means
like it.
substitution, sir.
uh,
Substitution. Imputation means substitution. Instead of null value, I need to fill them. Okay, we never keep sir data like empty, sir. Okay,
okay,
we never give a model an empty data, sir. Okay,
okay.
it should filled with values, sir. This is
So
called as
you mean to say, like, when we are having suppose 10 points in a time series,
ha
if
ha
there is some empty value,
ha
we
ha
need
ha
to fill it by
ha
mean or
ha
mode.
yes, sir. We have to fill by mean,
Oh,
median, or mode. But what technique with mean,
okay,
median, or mode? What technique? So that's what I was explaining, sir.
okay, got it.
So we never give model a empty data. Okay, so that's how we are technically trying to understand that what is the possible solution. Okay, so enjoyed the session.